You're listening to the Bare Metal Cyber Prepcast, created to help you succeed in your Cloud Plus certification journey. Learn more at baremetalcyber.com, where additional prepcasts, books, and training materials await. Let's get started. Cloud environments generate a continuous stream of telemetry, spanning multiple platforms, tools, and services. Without proper integration, this data remains fragmented and difficult to act upon. Integrating monitoring tools across the environment allows organizations to consolidate observability, coordinate incident response, and reduce manual intervention. This episode focuses on how tool integrations create unified monitoring ecosystems and how continuous verification practices ensure operational accuracy. These capabilities are essential for cloud operations and are explicitly tested on the Cloud Plus certification. The Cloud Plus exam covers more than just individual monitoring tools. It assesses understanding of monitoring workflows. Candidates may encounter scenarios involving toolchain coordination, alert routing failures, or verification breakdowns. To pass, candidates must recognize how tools connect, how data flows between systems, and how those connections impact uptime and response. Continuous verification is also emphasized, as it confirms that services remain functional and compliant throughout deployment and operation. Understanding these workflows forms the basis for advanced cloud observability practices. Monitoring tool integration refers to the process of connecting observability platforms with data sources, alerting channels, and response systems. This includes linking log collectors to dashboards, pushing alerts to incident systems, and synchronizing health data across environments. The goal is to streamline detection, escalation, and resolution without requiring manual effort at every step. These integrations reduce overhead, improve resolution times, and ensure that monitoring keeps pace with dynamic infrastructure. Common integration targets include alerting systems like PagerDuty, security information and event management platforms like Splunk, configuration management databases, and collaboration tools like Slack or Microsoft Teams. These systems work together to generate alerts, route messages to the right teams, and correlate logs or metrics from different components. Dashboards often aggregate input from multiple tools, creating a single operational view that spans infrastructure, applications, and services. Many tool integrations rely on application programming interfaces, commonly known as APIs. These interfaces allow tools to communicate by pushing or pulling data in real time. RESTful APIs, webhooks, and software development kits are used to create custom integration workflows between monitoring systems and third-party platforms. Cloud Plus candidates must understand how these mechanisms function and be able to evaluate their reliability, scalability, and limitations in various environments. There are two primary models for connecting systems to monitoring platforms: agent-based and agentless. Agent-based integrations involve installing lightweight software on hosts that collect and transmit telemetry. These agents offer detailed visibility, but may add overhead or require updates. Agentless integrations use external queries or event subscriptions to gather data without installing anything on the target systems. Choosing between these methods affects monitoring coverage, update intervals, and compatibility. Candidates should understand the trade-offs of each approach. Cloud-native toolchains offer built-in integrations for common services. For example, Amazon Web Services CloudWatch can monitor Lambda functions, Elastic Compute Cloud instances, and simple storage service buckets automatically. Microsoft Azure and Google Cloud offer similar capabilities. These native integrations simplify configuration and ensure tight alignment with platform services. Cloud Plus exam questions may require candidates to identify these platform-specific features and understand their default behaviors. Monitoring systems often integrate directly with ticketing and incident response platforms. When alerts meet certain conditions, tickets are automatically generated in systems like ServiceNow or Jira. These alerts may include metadata, such as severity level, resource tags, or suggested remediation steps. This connection ensures a closed feedback loop, where issues are detected, escalated, tracked, and resolved with minimal delay. Understanding this end-to-end flow is vital for both exam success and operational reliability. In continuous integration and deployment environments, monitoring is part of the pipeline. Pipelines may trigger monitoring steps that test application health, validate key metrics, or detect regressions. Canary deployments may be observed for issues before full rollout. These monitoring hooks are essential for ensuring that releases meet expected performance and stability criteria. When integrated properly, the pipeline can halt or roll back deployments automatically based on monitoring feedback. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Continuous verification is the practice of ensuring that systems behave as expected after each change or deployment. It extends traditional monitoring by actively validating performance, availability, and security controls during and after release cycles. Rather than waiting for problems to appear in production, continuous verification proactively confirms that services are stable, compliant, and functioning correctly. This practice supports DevOps teams, site reliability engineers, and compliance functions alike, all of whom depend on real-time assurances that systems are meeting defined goals. Verification should occur across multiple deployment stages, not just after changes are live. Pre-deployment checks, often called smoke tests, validate that essential components are in place and operational. During deployment, canary tests allow new code to run in a limited scope, providing early warnings if something goes wrong. Post-deployment tests define rollback criteria and validate whether changes met performance expectations. Tools may use synthetic monitoring or integration tests that simulate user actions to confirm functionality. Cloud Plus candidates should understand how these verification phases are sequenced and triggered. Automated health checks and regression tests are at the core of verification. These can be scheduled or event-driven and are designed to verify that the most critical aspects of a service remain intact. Health checks might validate that endpoints respond, that login flows work, or that data stores remain accessible. Regression tests ensure that recent updates have not broken existing features. When these checks fail, the deployment process may pause, trigger rollback procedures, or alert engineering teams. Cloud professionals must be prepared to configure and interpret these test results. Verification depends on well-defined metrics and clear acceptance criteria. Common metrics include error rates, response times, and resource utilization thresholds. Not all deviations require alerts, only those that cross critical boundaries or threaten user experience. Effective verification aligns each metric with an associated business goal, ensuring that alerts indicate real risk. Metrics must be application-specific, considering context and impact. For the exam, candidates should understand how to tie these metrics to meaningful thresholds and avoid alert fatigue through precise targeting. Monitoring and verification processes are deeply integrated into modern deployment pipelines. Tools such as Jenkins, GitLab Continuous Integration, and Azure DevOps can execute verification tasks as part of post-deployment steps. Observability platforms feed their results into dashboards and ticketing systems, allowing teams to track release health continuously. Cloud Plus candidates must recognize how these systems connect and how telemetry data from observability platforms informs deployment status and success metrics. When monitoring detects a significant drop in performance or availability after a release, rollback triggers may activate. Rollbacks revert the system to a previously known good state, protecting users from extended disruptions. These rollback decisions are based on verification data collected in near real time. Rollback automation requires that metrics be accurate, timely, and relevant. Understanding how rollback logic functions and what monitoring data informs it is a key concept covered on the Cloud Plus exam. Keeping monitoring systems in sync with the infrastructure they observe is critical for reliable operations. As environments change, new hosts, containers, or services monitoring tools must be updated to reflect those changes. Drift occurs when monitoring tools fall out of alignment, either by missing new resources or by continuing to watch decommissioned ones. Drift leads to blind spots and false alerts. Regular audits, tagging practices, and automated updates prevent this drift and ensure monitoring accuracy over time. Shared dashboards and reports help teams stay coordinated during continuous verification. These visual tools show live metrics, alert status, release performance, and system health in a centralized view. When shared across teams, dashboards enable unified decision-making and faster response times. Reports generated from verification data support audits, service-level agreement validation, and internal reviews. Candidates should understand how dashboards contribute to transparency and how reporting supports operational governance. Ultimately, integrating monitoring tools and implementing continuous verification ensures that cloud environments remain observable, responsive, and resilient. These practices tie together technical telemetry with business expectations, making them essential to modern operations. Mastery of tool integration, workflow design, and verification logic prepares Cloud Plus candidates to design systems that detect problems early, respond intelligently, and protect service quality at scale. Thanks for tuning in to the Bare Metal Cyber Prepcast, your trusted source for cybersecurity news and insights. Remember to subscribe at baremetalcyber.com so you never miss an update. And visit cyberauthor.me for best-selling cybersecurity books that equip you with expert knowledge. Until next time, stay secure and stay vigilant.